Hello, my name is Paras Fadzare. Today I am presenting the topic understanding the functions and features of OSI model. So, first of all, what is OSI model? OSI stands for the Open System Interconnection model. Was developed by the International Organization for Standardization in 1980s to create a universal framework for how the different systems communicate across the networks. There are seven distinct layers. Each layer handles the specific network communication functions, and so here's the layer 1, which is physical layer. The core function of the physical layer is to transmit the raw bits as an electrical or optical signal over the physical media like copper cables, fiber optics, and wireless frequencies. The key responsibilities of this layer is that it defines the electrical voltage levels and signal timing, also specifies the mechanical connector pin layouts, manages the bit synchronization and transmission rates, establish the physical network topology. In physical layer, there are some devices and protocols. In devices, we have hubs, repeaters, network cables, modems, and in protocols, we have Ethernet physical specifications, Bluetooth, and USB. In layer 2 we have data link layer. In data link layer, layer organizes the raw bits from the layer 1 into organized frames and manages direct node to node communication across the local network. It includes frame organization, media access control, error management, and key device protocol. In frame organization, it packages the bits into frames with headers and tailors containing MAC address and error checking information. In media access control, it manages the access to the shared physical media and prevents collision through the protocols like CSMA and CD. In in error management, it detects and corrects the transmission errors. And in key devices and protocols, it includes switches, bridges, Ethernet, like 802.3, PPP, and HDLC. When we coming at level 3, there is a network layer. The network layer handles the routing and logical addressing, enabling the data packets to travel across the multiple interconnected networks to reach their destination IP address. Routing and it includes routing and forwarding. It routers analyze the destination IP addresses and determine the optical path through the network using routing algorithms. In packet management, it includes the fragment large packets for network compatibility, resemblance fragmented packets at destination. Manages traffic congestion and load balancing. Also implements the quality of service, that QoS policies. The key protocol of this is IP, that is IPv4 or IPv6, ICMP, and ARP. In layer 4, we have transport layer. The transport layer guarantees the reliable end-to-end data delivery by establishing the connections, managing data flow, and handling recovery between the source and destination application. It includes TCP and UDP. In TCP, it is connection oriented. It is reliable order delivery with the error correction, and in UDP, it is connectionless, fast, best effort delivery without guarantees. The main core responsibilities of the transport layer is the sometimes the data managing the flow control, multiplexing multiple connections, ensuring the complete and ordered arrival, eliminating the duplicate packets. In layer 5, it is security session layer. The session layer, it establishes the communication session when the applications connect and maintain the active sessions during the data exchange, and clearly terminates the sessions with when complete. In synchronization, it includes the coordinates bidirectional dialogue between the application. It is places checkpoints in data statement for recovery, prevents data loss through the session restoration. It manages the token control of for turn taking communication. In layer 6, it is a presentation layer. The presentation layer transforms data from application format to the network, ensuring the different system can understand and each other despite variations in data representations. It includes encryption, compression, and format conversion. In set 7, application, it have application layer. The application layer is where the end users interact with the network. It provides the network service directly to the software applications like web browsers, email clients, and flight transfer programs. It includes HTTP, HTTPS, that is web browsing and secure web connection. It has SMTP or PPO3. It is email sending and retrieval services. PFTP and SFTP. It is a file transfer and secure file exchange service. In DNS, it is domain name resolution to IP address, and it is and a telnet and SSH means the remote terminated access and secure shells. So here's the point why the OSN model is still matters. Although the TCP or IP dominates the modern networking, the OSN model remains invaluable for its understanding, designing, and troubleshooting network system. Uh, in universal language, it provides a standardized terminology that enables the professionalism worldwide to communicate about network architecture and its functionality. System troubleshooting, it allows the IT teams to isolate the network problems to specific layers and dramatically reducing the diagnosis time. In technological integration, enables the modulation development where the new protocols and techniques are incorporated at the appropriate levels. In education foundation, serves as an essential conceptual frameworks for teaching network, and it helps building solid professional expertise. So thank you.